What if an AI could do more than solve math problems? What if it could discover new mathematics entirely on its own, with no human guidance, and publish the results? In February 2026, Google DeepMind announced Aletheia. It solved 4 open math problems that humans hadn't cracked, and it wrote a research paper from scratch, with no human involved at all. This is how it works. To understand Aletheia, you first need to understand the engine behind it. Gemini Deep Think. This is Google's advanced reasoning mode built into Gemini 3. Instead of answering immediately, Deep Think spends extra time thinking through problems step by step before giving you a response. This is called test time compute scaling. The idea is simple. The longer a model reasons before answering, the better its answer gets. Deep Think scored 95% on the IMO proof bench, a test of Olympiad-level mathematical proofs, and it did this using 100 times less compute than the previous version. But Deep Think alone isn't Aletheia. Deep Think is the brain. Aletheia is the full agent built around it, and the core of that agent is a 3-step loop: generate, verify, revise. First, the generator produces a candidate proof or solution using Deep Think's reasoning. Then a natural language verifier reads through the entire solution and checks it for logical errors, gaps, or invalid steps. It classifies every solution into one of 3 categories: correct, fixable, or fundamentally flawed. If a solution has minor issues, the reviser patches them without starting over. But if the solution is fundamentally flawed, it gets thrown out entirely and the generator starts fresh with a different approach. This is critical. The system doesn't stubbornly refine a broken proof. It knows when to abandon a dead end. Aletheia can also admit it simply cannot solve a problem. Instead of hallucinating a fake solution, it stops and says so. This might sound like a small thing, but for research, it's huge. A confident wrong answer is far more dangerous than an honest, "I don't know." Aletheia doesn't just reason in isolation. It uses Google search and web browsing to look up existing research papers and mathematical literature. This prevents a common problem in AI: hallucinated citations. When Aletheia references a theorem, it has actually read the source. The researchers also used a technique called balanced prompting. Instead of asking Aletheia to prove something is true, they ask it to simultaneously try to prove it and try to disprove it. This reduces confirmation bias, where the model locks onto one answer and forces the evidence to fit. So what did Aletheia actually accomplish? DeepMind tested it against 700 open problems from the Erdős Conjectures database. These are problems posed by Paul Erdős, one of the most prolific mathematicians in history, many of which have remained unsolved for decades. Aletheia autonomously solved 4 of them, and for one of those, problem 1051, the solution was so strong that researchers were able to generalize it into a broader result and publish a separate paper. On top of that, Aletheia produced Feng 26, a paper on eigenweights in arithmetic geometry, entirely without human intervention. That is a first. To classify these achievements, DeepMind introduced something called Mathematical Research Autonomy Levels. Think of it like the self-driving car levels, but for AI research. Level 0 is negligible novelty, where the AI contributes nothing meaningful. Level 1 is useful assistance. Level 2 is publishable research, where the AI contributes work good enough for peer review. Level 3 is a major advance, and Level 4 is a landmark breakthrough. Aletheia's current work sits at Level 2. No AI has reached Level 3 yet, but the framework itself is significant. DeepMind is building the measuring stick before the race even starts. But let's be clear about what Aletheia cannot do. It still suffers from confident hallucinations, where it produces technically convincing but wrong arguments. It can exhibit confirmation bias, locking onto a proof strategy and ignoring evidence that the strategy is failing. It also has alignment friction. Sometimes it resists exploring unfamiliar territory or pushing into unconventional approaches. Human mathematicians still need to steer the direction and ask the right questions. The AI handles the computation, but the intuition about what problems matter still comes from people. Aletheia is part of a bigger shift at DeepMind. They also announced breakthroughs in physics where Deep Think solved a cosmic string radiation problem using Gegenbauer polynomials. And in computer science, it cracked a decade-old optimization conjecture by constructing a combinatorial counterexample. This is the pattern. AI is moving from answering questions humans ask to discovering answers humans haven't thought to look for. Aletheia generated 18 research contributions across algorithms, machine learning, information theory, and economics. We're watching AI transition from a tool that assists research to an agent that conducts it.